Hello and welcome to Elimu TV. My name is Mr. Kamau and I'm taking you through Form 2 Mathematics, and our topic in today's lesson is cube roots of numbers using mathematical tables. In our previous lesson, we learned how you can get cube roots of numbers which are exact cube roots. Numbers such as 8 or 64 or 27 or 125. These are numbers that have exact cube roots. And we say that to get the cube root of such a number, you first of all express that number as a prime factor of, as a multiple of its prime factors. And after you do that, when you express it in that form, then the powers of the prime factors are supposed to be divisible by 3. E.g., 125 can be written as 5 times 5 times 5, which is equals to 5 to power 3. You can see 3 is divisible by 5, which is the power of 5, and therefore the cube root of 125 is equals to 5 to power 1, which is equals to 5. Now today, we'll see how we can get cube roots of other numbers that are not exact cube roots. Example, find the cube root of 44.28. So go to cube tables and look for the number just below 44.28. So when you go to the cube tables, you have these numbers. You have these numbers here. So within this body of numbers, you will find a number that is just that. We say that the next number that is below 44.28. So when you do that, you will find that that number will be 43.99. And by inspection, if you inspect that correctly, you will find that this number is the cube of 3.53. The procedure is as in our previous lesson, whereby under column X, you find 3.5, the first two digits, and then under the major columns, you find come under column 3, and that is where you will find the number 43.99. This is the number that is closest to 44.28 and below it. Now, we need 44.28. So, how much is remaining from the 44.28? We will say 44.28 subtract 43.99. And when we do the subtraction, we get that number is 29. What are we supposed to do with the number 29? We will go to the minor columns. Now I think I should bring back our cube tables so that I can explain. As you see, we have 3 sections of columns on the cube tables. There is the column X, then from there we have the major columns starting from 0, 1, 2, all the way to column 9. And then we have the minor columns where it says add. And we have column 1, 2, 3, all the way to column 9. So we are now at 3.5 and we have come under column 3 to find the number 43.99, which is just below 44.28. So we still move along that row. We are looking for 29, and we have to find it under the minor columns. So our task here is to find under which column do we find 29. So if you do that, there is no 29, so you look for the next one which is closest to that, and that is 30. You will find 30 under the minor column, and that 30 falls under column 8. It falls under column 8. So what does that tell us? We add 8 to our previous answer. So we had 3.53, we add 8. And we will say, therefore, 3.538 cubed gives us 44.28 approximately. And therefore, the cube root of 44.28 will be approximately 3.538. And that will be to 4 significant figures. It is not exact, but it is very close if we are considering only 4 significant figures. So basically, that is the procedure of getting the square root, the cube root from the cube tables. Now I think I will go to finding the cube root of a number that is greater than 1,000. How do we get that? Now, let's say you have been asked to find the cube root of 1945, 1945. Find the cube root of 1945. Now, of course, you notice that this number is greater than 1,000. Now, all numbers, if you are getting the cube root and it is greater than what we have in the tables, is greater than 1,000, you are supposed to express that number as a multiple of itself and a factor that has a power divisible by 3. So I'm going to write this as the cube root of 1.945 times 1,000. So that if you say 1,000 times 1.945, it takes you back to the original question. This can be written as the cube root of 1.945 multiplied by the cube root of 1,000, which is equals to the cube root of 1.945 multiplied by the cube root of 1,000 is supposed to be 10. So from there, we now use our method of getting the cube root using the cube tables. So in the table, just as we had said in a previous example, go to the cube tables and look for the number that is just below 1.945. From the cube tables, I'm using my cube tables, and what I find in my cube tables, the number that is just below, that is the one which is closest to 1.945, but below it is 1.907. So we have 1.907, 1.907, and it comes under, it is actually the cube of 1.24. 1.24. So this means that we have 1.24 cubed is equals to 1.907, which means the cube root of 1.907 is 1.24. So we need to find the fourth significant figure, the fourth digit here. So while we are still on that position at 1.907, we move to the right along that row. Now, what we will be looking for? We will be looking for the difference between 1.945 and 1.907. So, if we do the subtraction, we'll get, this will be 2, this is 3. So, we'll be looking for 32. Where? We'll be looking for 32 at the minor column section. So what we have now is 1.2, and then under this, under 4, we have 1.907. So we move like this until we get the difference, which is 32. And on my mathematical tables, when I do that, you can also do the same in your mathematical tables to confirm. I come under minor column 7. The number I find there is 33. The other one will be under minor column 6, which will be 28. But 28 is further away from 32, so I opt for 33. So 33 occurs under minor column 7. So that tells me that my fourth digit here should be 7. Will be 7. And that will give me approximately 1.945. And therefore we can say that the cube root of 1945, cube root of 1945 is equals to cube root of 1.945 times 10, which is equals to, as we have found out, which is equals to 1.247, this number here, multiplied by 10, which will come to 12.47. And so that is how to get the cube root of a number greater than 1,000. Now, I would like to make a correction. This is not 32, it is actually 38, which now changes everything, because when you go to the minor columns, you find that we have 37. The difference is 37, which brings us to 1.248. And therefore, I will correct this. You must have noticed that mistake, and I'm sure you have acknowledged the correction. So that is our method of determining the cube root of a number that is bigger than 1,000, which cannot be found in our cube tables. We are now left with getting the cube root of a number that is less than 1. A number that is less than 1. So let me give you an example. Find the cube root of 0.3831. The cube root of 0.3831 from the cube tables. Now here, remember we have to express this number such that its second factor will be a number whose power is divisible by 3. So I want to write 0.3831 as follows. So this will be 0.3831 is equals to, we can write it as 383.1 divided by 1,000. Such that when we say cube root of that, it means cube root of 383.1 divided by 1,000. And from there, we will simply say this is equals to the cube root of the numerator, 383.1, divided by cube root of the denominator, that is 1,000. Which gives us, this is equals to cube root of 383.1 divided by 10. Now, we can get the cube root of 383.1 from the tables. Go to your tables. And within the tables, look for 383.1. 383.1. Now, we have, in the tables, we have 382.7, and we also have 384.2. So 383.1 lies between those two. And since we cannot get the exact one, then we take the lower one, that is 382.7. Now the cube root of 382.7 from your cube tables will be 7.26. So we'll have 7.26. 7.26. Now that is the cube root of 382.7. So there is a difference between this and that. So that difference, we calculate it, we'll say 383.1 minus 382.7. So we subtract, we get 4, and that is all, 0.4. So this is the difference. And this difference, we look for it in the minor columns. So on the tables, we are now at 7.2, the first two digits. Then we are under column, major column 6. Major column 6, that is where we are getting 382.7. Now we move along this to find the difference, which is 4. And when we do that, we'll find that 4 comes under, and that comes under minor column 2. Under minor column 2, we have 3, which we are supposed to add. And therefore, we will say the fourth digit there is, sorry, not 3, is 2. Is 2. Which means, therefore, that the cube root of 383.1 is approximately equals to 7.262. So, to answer the question, what is the cube root? What is the cube root of 0.3831? We'll say this will be equals to 7.262. Remember, we are dividing by 10, and this comes to 0.7262. That will be our final answer. And so that's how to get the cube root of a number less than 1 from the cube tables. I hope you will continue to do more practice on this in order to familiarize yourself with this type of questions and how to solve them. I am yours, Mr. Kamau, for Form 2 Mathematics, and I hope you have enjoyed. Thank you.